Aloha BC 82, polar area. All right, so this is going to take us back to our AB days, and we're going to find the area. Now, it's not the area where we go top minus bottom, right minus left, but now it's using our polar axis and our radii, okay? So if you notice our little formula here, it's 1/2 the integral from A to B, alpha to beta, of your radius or your polar curve squared d theta, right? R is always in terms of theta. So just a brief description of what this all is about. We all know that little integral symbol, right, class? It means we're going to take an infinite amount. When we were in rectangular coordinates, they were rectangles. In polar coordinates, they are these radials. So let's say I take that radial right there, and I add it to that one and that one and that one, and I have an infinite amount of them, right? And if I just keep on doing that an infinite amount of times, I actually get that entire area. So that's what we're doing here. So our formula is 1/2, right? Alpha to beta, okay? And those are going to be angles, okay, class? And then it's just our polar equation squared, obviously d theta, because everything will be in terms of theta. That's it. Okay, so we don't have to worry about a top minus bottom. There might be other things we have to worry about, but we don't have to worry about a top minus bottom, right minus left, like we do in rectangular coordinates, all right? The one thing that you have to be very good and efficient at to be able to be good at these problems is being able to graph these like we worked the other day in class. All right, so let's look at example 1. It asks me to find the area bounded by the graph r equals 2 plus 2 sine theta. So you should go ding, ding, ding. That's a cardioid, and a cardioid is like a cardiovascular surgeon, which means it's going to be a heart. And that is sine. Sine means it's going to be symmetric about the y-axis. So let's go ahead and draw a quick graph of this, and you should be able to draw these a little bit quicker, right? And if we need to, it's just an angle there. So I can just use my basic one, 0, pi over 2, pi, 3 pi over 2, and come back here to 2 pi, right? All right, so let's go ahead and do that. If I put a 0 in there, it'd be 2 plus 0, which would be 2. And the one thing that you want to do here and you want to get good at, and it's not going to be fun here because my marker's really big, is that you have to draw these very accurately, okay? So I get that. Now if I plug a pi over 2 in there, I'm going to get 2 plus 2, which is 4. 1, 2, 3, 4. There. So hopefully we know it is a heart. It's a cardioid. So it's going to look like that. Plug in a pi. If I plug in a pi, I get 0, which means I still get a 2. Right? That's a cardioid for sure. Plug in a 3 pi over 2. It gives me a -1. Ooh, it's going to give me a 0. But remember, this is our heart. Okay, so it comes back here to the polar. Right? That's my one polar 0 here. And to finish it off, okay, we're right back there. So what we're going to do here is we're going to find the area of this curve. All right, so how the heck do I find the area of this curve? There's many ways you could do it, okay? So let's go over a couple. One way, so it's like shading that whole thing in. Okay, I'm going to do 1/2. That's the formula. The integral from 0 to 2 pi. Now, if I go from 0 to 2 pi of my curve, of my polar curve, sine theta, square d theta. That's all I have to do. What it is, and I want you to understand this, let's go ahead and do blue here, okay? It's going to draw it, and it's going to draw the first radial is going to be that radial right there, okay? And then it's just going to go like this, right? And let's pretend I have an infinite amount. That'd be from 0 to 2 pi. Important to understand that. Okay, the next would be pi over 2 to pi. Everyone with me? And then from pi to 3 pi over 2, it's just that little bit. And then from 3 pi over 2 to 2 pi, it's that little bit. And then how about that? I get it all shaded in. So hopefully you're thinking, you're like, hey, are there other things that you could do to get the area of that? Uh-oh. Let's see if we can check here. I'm going to just do a different color here. I'm going to go ahead and pick this gross one. But what's another thing I could do? I bet you I could maybe go, ooh, there's a little symmetry about the y-axis going on here. All right, so if there's symmetry about the y-axis going on, how could I use that to my advantage? Well, couldn't I just draw it from pi over 2 all the way to what? Pi? No, that wouldn't be enough. All the way to 3 pi over 2. So another formula I could do, I could go 1/2, and I could double it. And that ends up being important if I ever have to do this by hand, because 1/2 times 2, right? Uno, ichi, right? Kind of get rid of that 1/2. But this time I'm just going to go from pi over 2 to 3 pi over 2. And once again, it's just my r squared d theta. It's going to give me the same answer. What else could I do? Let me shade this all this color, right? If I double it, it's going to give me all of that. What else could I do? Let's go ahead and let's go with red, our final one, okay? Another thing I could do is I could double up. Let's just go like this. Let's go, could I go from like here? Well, that'd be 3 pi over 2 all the way to pi over 2. But I wouldn't be able to use 3 pi over 2 because it'd mess up my calculator, right? It'd be like backwards limits. So instead, what I'm going to do is I'm going to go negative pi over 2 to pi over 2, right? Doesn't that make sense? That means I'm going to start here. I'm going to start making these. They're called radials. And you're going to have an infinite amount of them. So it's going to give you exactly half of it. So if I double it, I'm good to go. I'm going to little r squared that bad boy. Boom. Now we're going to save some time by not getting out my TI-80 and plugging it in my calculator. But you guys, please plug those into your calculators and make sure you get, I got it right there too, 18.849ers. Okay, so make sure you get that. Okay, let's keep moving. All right, because we're going to have to practice these guys. We're going to have to make sure we're very good at graphing these. Oh, example 2. How about this bad boy? It says to find the area of one of those petals, okay? So it kind of gave it a hint away that it is a rose, okay? Well, if it's a rose, I might have to be more involved here, right? Whenever we did roses in class, we always wanted to know what our polar zeros were. So I'm going to go 2 sine of 3 theta is equal to 0. Remember, that means when is sine of 3 theta equal to 0? Well, sine is equal to 0 at 0 plus 2 pi n. And it's 0 at pi plus 2 pi n. So remember, what I need to do for each one of these guys is I need to divide by tree. And I would get 0 over 3 plus 2 pi over 3. So that would give me polar zeros of 0, comma, 2 pi over 3. Remember, there's one in between those two. And if I divide the bottom one by tree, I get pi over tree, right? That's the one in between. Plus, if I divide that, it'd be 2 pi over 3. Okay, so what the heck is pi over 3 plus, tree pi over tree, which is pi. All right. So let's graph this, and guess what? I only have to graph one petal, right? Shouldn't I only have to graph one petal? I think so. And then I just have to observe and be creative and be smarty pants. All right, let's go. It's sine and be perpendicular to the y-axis. If I start this out, 0 would be 0, right? Because boom, so it's right there. All right. My next polar 0 is pi over 3, which would be 0. So I need something between 0 and pi over 3, which, would be pi over 6. I could choose pi over 4, but pi over 6 is going to work out real nice, right? If I plug a pi over 6 in there, I get 3 pi over 6, which is pi over 2. Sine of pi over 2 is 2 times is 2. So where is 30 degrees? It is right there. And I'm going to go 1, 2. And so once again, I apologize, but I get that. Oh, snap. I should probably make this super duper big. So I'm going to get rid of the rest of that stuff, class. I need it bigger. I apologize. Okay. But we start at 0 and we're at 30 degrees. I'm going to make 1, 2. So it's out there and it's going to look like that. Oh, snap. And then, right, it comes back. And it's important to know that that's at pi over 6. So if you notice, if I drew these radials, right, let's draw them in a different color. I'm going to start at 0, but then I'm going to start just drawing these guys. And then if you notice, when I get to pi over 6, I have drawn half of the puzzle, half of the petal. And snap, I could use symmetry, right? One petal would be 1/2. Let's double that bad boy. I'm going to start at 0, right? And I'm going to have all these guys, and I'm going to stop at pi over 6 because that's going to be half of a petal. And then I just have to square my polar curve, right? That's going to give me an answer. And some of you would say, well, couldn't you just go from 0 and do the entire petal? Because pi over 3 it would bring me all the way back, right? For sure you can, right? And then but you're not going to double it because that would be your entire petal. So we're going to square that bad boy. Once again, your job is to plug that into the calculator, and we get 1.047. I can't remember if I truncated that bad boy, truncate, or if I rounded that. Okay, remember AP, you can do both, but it better be the 3 decimal spots. All right, let's keep rolling. Let's keep rolling because these get so fun. All right, here we go. So what's this dude ask? This dude asks for one pedal, easy peasy, job on easy, but that's symmetric about the x-axis. Okay, so let's do this. All right, if it's a pedal, I want to know what my r theta, right? I got to graph that, and it's so helpful if I know my phases, right? Polar zeros, which would be when 4 cosine of 2 theta is equal to 0, which would be when cosine of 2 theta is equal to 0, which would be when 2 theta is equal to pi over 2 plus 2 pi n, or when it's 3 pi over 2 plus 2 pi n. All right, so I'm going to get this guy started. I will plug those in. I'm going to try to save a little bit of time. If I put a 0 in, right, that's not going to be a polar 0. Okay, but my first one will be at pi over 2. Whoops. See? Let's not save time. I got to divide by 2 on all those. And how about it, right? I did bad. I was going to try to save time, and look what happened. My pen ran out. Let's see if I can do this guy. With the rest of it, yeah, can I? Well, at least start. Let's give it a shot. Okay, so that means theta, right? Because I got to divide. It's going to be pi over 4, right? Plus 2 pi n over 4. And my other one is going to be 3 pi over 4 plus 2 pi n over 4. So I'm going to have pi over 4. I'm going to have 3 pi over 4. I'm going, oh, you know what? Let's stop there because it's just one pedal, right, class? Just one pedal. So pi over 4 would be my polar 0. So let's go 1, 2, 3, 4. Make my graph. And it's not fun that I have to use this guy, but at pi over 4, I'm going to be back here at the polar 0. So there we go. Oh, snap, that's half. Is that half of a pedal? For sure that's half of a pedal. But imagine if I kept on going on. My next polar 0 would be 3 pi over 4. So that's going to be 0. What's in between those two? Pi over 2. If I plug a pi over 2 in there, I get pi. Ooh, I get negative 4. I get negative 4. That's pi over 2, though. And if it's negative, that means I'm going to go down 1, 2, 3, 4. So you know what's interesting? Oh, my gosh. So if I start drawing this, that's 0, right? If I keep drawing that, oh, snap. That's half. So guess what I could use? Symmetry again. Let's double that up. And let's just go from 0 to pi over 4, right? Oh, yeah. And then I just have to do my 4 cosine of 2 theta squared d theta. How about that? You know what else I could have did, which is pretty intuitive, is I could have drawn this whole guy, and then where does it go? It goes to draw this guy. Oh, snap. That's like Pac-Man, which, by the way, I dominate. Try to challenge me at Pac-Man or Galaga. And that is a full pedal. So I could go from 0 to pi over 2, because that makes a complete pedal. And so there's many other ways that you could do these, okay? But you guys plug that into your calculator, and if you do it correctly, you get 6.4, ooh, snappy, 6.28. I don't know if that's truncated or rounded. See you in a bit. Let me get it so I can do it on that overhead. All right, class, we've got 2 more. Okay, 2 more. We're going to do example 4 in class. Please remind me to do it in class, all right? What I would love is if you tried that on your own, but make sure I do it in class, all right? All right, here we go. Let's do this next one. Oh, it gets so fun now because we get to graph 2 of them. All right, so let's graph 2 of these guys. And actually, I need it really big, okay, because I got such a big pen here. And if I graph this, I hope we know that's a circle, right? And if I plug a, let's get, okay, that's a circle. 0, I could do my little table. I don't probably need a table, right? Because there's no double or triple angle. It's not a rose. It's not getting crazy on me. But if I plug a 0 in there, sine of 0 is 0. And then pi over 2. 1, 2, 3. Boom. And I better know that it's a circle. Now, for these problems, you have to try your best. Oh, snap. That's a decent circle. Decent. Okay. But that's a circle. And remember that got drawn from 0 to pi units. If I go to 2 pi, it kind of retraces it. Important to understand that. All right, now let's graph the other guy. I'm going to make it blue. Okay, what's that, dude? Hopefully we remember what that is. Do we remember? If you're not sure, let's graph it. But hopefully you remember what it is. It's kind of like one of those dimpled cardioids or limosons, right? But it's dimpled, right? Because that 2 is bigger than the ichi. But let's plug in a 0. If I plug in a 0, it's 2 minus 0, which is 0. So I'm still, ooh, snap, 1, 2. That sign, that'd be 0. 2 minus 0 is 2. So I actually start there. What about at pi over 2? At pi over 2, it'd be 1. 2 minus 1 is 1. So it actually looks like that. Okay, and remember, it's kind of like that. It's not quite a cardioid or a limoson. It's dimpled, right? Which means it won't have that loop and it won't get back to that polar. It won't have a polar 0. Okay, next, let's go to pi. If I plug a pi in there, I get 0, which means it's still 2. It's very important to make sure you draw these accurately. Okay, so we're there. Let's go ahead and go to 3 pi over 2. And if I, so this one, very interesting. This one gets drawn, though. Very important to pay attention to that. You'll see why when we do some of these tougher problems. Okay, but if I plug a 3 pi over 2 in there, I get a -1. So I get 3. 1, 2, 3, right? Because it'd be 2 minus -1. So it's that guy, which means it comes down. Okay, and then if I put a 2 pi in there, I get 2 again. So that's just coming back here to 2 pi, and it's there. There we go. Oh, sweet graph. Now let's just make sure we read correctly and we shade the area we're trying to find. All right, here we go. It says find the area inside of the red, but outside of the blue. Do I have a highlighter on here? I don't think so. Darn it. So let's make it this gross color. All right, what area am I talking about? I'm talking about this. And if you notice, there's some symmetry going on there, right? They're both sides, so they're both symmetric about the y-axis. So if you're really, really good, you're noticing that there's something very important here. What color should I make that? Let's make it red again. And it is this intersection point, right? That radial, where the heck is that it? I bet you I'm going to need it, right? I bet you I'm going to need it. So let's go ahead and do that. How do I find out? Well, we all know, how do I find out where two graphs intersect? We simply set them equal to each other, right? So we said at the beginning of this lesson, you're going to have to be really good at your unit circle. Add that over, right? And the other really good thing about doing this very accurately is that looks like it's 30 degrees. And guess what? It is 30 degrees, okay? And if I could find this intersection point also, right, there's going to be another one. What would that be? That'd be at theta equals 5 pi over 6, right? 150 degrees. All right, that's probably important. So we're trying to find that green shaded region. Whew. So what the heck am I going to do? Well, we want to think radials. Okay, we want to think radials. Let's go back to blue here. Okay, so let's just focus on the circle. The circle's red. Let's go red, 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 red. Okay, the circle's red. So if I was to start at 0 degrees and do the circle, oh snap, that'd give me all that. And I don't want that, right? I want that green, okay? However, if you notice, if I go from 0 to pi, it's going to give me all of that. So what do we think, class? Well, I don't know about you, but if I go from 0 to pi, it gives me all of that. Well, what about, all I really care about is starting at pi over 6. So let's make that clear again. You know what? Oh, no, I can't. But let's just go from pi over 6 to pi over 2. And you know what? I'm going to use doubling because doubling makes these polars really, really nice. So I'm going to double, and I'm going to go the integral from pi over 6, and then I'm going to tell you why I'm doing this in a moment, to pi over 2, and I'm going to do this for the circle, which is 3 sine of theta, and I'm going to square that so it gives me the area of the red. And remember, this part, gosh darn it, come on. This part is not, it's kind of whitish. That's from that part from 0, okay, that's not. Okay, so doing this piece right here will give me all of this red, right? But I only wanted that green. So guess what I'm going to do? I am going to use my dimpled cardioid, and I'm going to go from pi over 6 to pi over 2 and double that. And it's going to subtract that out. And then it will give me that green region that I wanted from the beginning. So let's see. Hopefully I don't lose you guys. So I'm going to subtract in this situation, right? And I'm going to double it again. It's always good to double, okay? And I'm going to go from pi over 6. And you're correct, class. You do not have to double if you don't want to. You could go from pi over 6 to 5 pi over 6, okay? And I'm going to go pi over 6 to pi over 2 of the dimpled cardioid, or le machin d theta, but make sure I square. And you're going to put that all into the calculator. And guess what? You don't have to put the 1/2 and 2's in there because they'll cancel themselves out. And if you do it correctly, you get 3.685. Okay, hopefully that makes sense, class. If it's really, really tough, don't worry. We focus an entire day before we take our big test on parametrics and polars on these areas, okay? Just try your best. And you know what? The best thing to do is to try it again from scratch if you got really lost, all right? But let's try one more of these bad boys. And I know I apologize once again for how little this dude is, okay? Makes seeing these kind of tough, all right? But here we go. We'll try to draw this one big. That is a circle. But it's a circle and its cosine, which means it's going to be symmetric about the x-axis, right? 0, 3. At pi over 2, it's going to get back to the polar, right? And then once again, we want to notice, and you'll see why when we do some tougher problems, that from 0 to pi, that finishes my circle, okay? This right here is 1 plus 1 cosine theta, which is a cardioid, okay? So it means it will be a heart. And let's graph that guy. If I put a 0 in there, I get 1. 1 plus 1 is 2. If I put a pi over 2 in there, I get 0 or 1. 1 plus 0 is 1. So there's the start of the cardioid. Once again, that's probably important where they intersect. If I plug a pi in there, I get a -1. So it comes back to the polar. And remember, it's a cardioid. It's very important you know that. If I plug a 3 pi over 2 in there, I get 0, which is 1, right? Which goes there. And then I finish it up by putting a 2 pi in there, which will be 1 plus 1, which is 2. So here we go. Gosh, this thing does not have like that single eraser, right? But what is important right now is, I'm going to make it blue because I kind of did a bad job, is that radial right there. Where is that? Sweet. Okay, where is that theta at? Okay, now how do I find out where that theta is? Well, it's where they intersect. Where do they intersect? They intersect when the two equations are equal to each other. And you can kind of take a guess. Take a guess. What does that look like? That looks like pi over 3, 60 degrees, right? If I subtract that over, I get 2 cosine theta equals 1. Cosine theta equals 1/2. And remember, there's 2 of them. So remember, my answer would be pi over 3. Or what is that guy be? Pi over 3, 2 pi over 3, 4. And that'd be 5 pi over 3, right, class? 300 degrees. All right, so what we're trying to do here, let's see. Find the common area. All right, the common area would be, let's make that. Can I do it here? Oh, I can. All right, let's make it. The common area would be all of this stuff and all of this stuff, right? That's the common area. Okay, that's the blue. Radial, common area. So the common area would be this stuff in here too, right, class? It'd be this stuff too. But why are those radials important? Hopefully you see it. Here we go. We're going to 1/2. We're going to, let me get back to my red pen. Okay, and remember 0. Let's do blue here. Okay, because if I use red and I go from 0, I'm going to go let me get my red. If I use the circle, I'm going to go from here to here. And do I want all of that area? I don't, right, class? I don't want all that. I do want the area of the blue, though, right? Because that will make the green. And I'm going to draw those radials. And what am I going to go to? I'm going to go to pi over 3. So I'm going to go 1/2. And I'm going to double it. I'm going to use my symmetry. Why not? Because then I don't have to deal with that guy. And I'm going to go from 0, right? Because that's 0. and I'm going to go all the way to pi over 3. Okay. I'm going to use the cardioid, which is 1 plus, because the cardioid is blue. Pen's working all right now, right? How about it? Okay. But if you notice, this little piece right here, I'll make red. But from my radial where they intersect to there, that's all red. Right, class? And I don't want to use blue, because if I use blue, I'll be getting too much, right? That's not the common, right, class? Because the circle's not outside that. So this time I'm going to add some area. And believe it or not, it doubles up with this. So I'm going to 1/2, I'm going to double it up. And what does it double it up from? It doubles up from the radial, pi over 3, to when? When does that circle get back to the polar, right? When we graphed it, it was pi over 2. And then I'm going to use the circle, 3 cosine of theta squared d theta. All right, and then you plug all that into your calculator, and I get 3.927. You know what would be the best idea right now? It's every problem we just did. If you wasn't flying with you, try to see if you can do it on your own. We will practice it in class. Aloha, that's it for your next video. So try to do some of this on your own. That's why I'm not making this video any longer. Aloha.